Jambo tena. Today I'm here to present you an introduction part of pressure physics from 1. Welcome. Pressure. You can always find me through the number that is on your screen of 757 01 90 then 11. Welcome. Let's look at pressure. What is the real definition of pressure? We will define pressure as the force acting perpendicularly per unit area. So I can say is the force acting perpendicularly per unit area. The SI unit for pressure is Newton per meter squared. SI unit Newton per square meter. In exam, when you're asked about things to do with measuring, or you write down, state the SI unit of something, then you're supposed to state in words, not in symbols. So the symbol for this one is Newton per square meter, like that. We can now proceed. So from the definition, you can say pressure, which is noted as P, is given by the acting force F capital over area in square. Sorry, this one is A. For you to be on a safer side, you're supposed to be having all these quantities in terms of you place them in their SI units of the moment you are substituting. And therefore, these will guide you so that you can stay safe. We can now continue to the next step. You can use the initials directly. P is equals to F over A. From this formula, now, this you can call it equation 1. This means that force will be given by area times pressure. You can call this one 2. And then area will be made by force over pressure, P. Because this is one equation 3. Let's look at pressure in solids. We have the thing to do with the weight of a solid. And in this case, I'm going to share the slide notes so that you may see. So the moment you're having pressure in solids, then we can say force exerted by a solid resting on a surface is equal to its own weight. Is equal to its own weight, as you can see on your screen. So in this case, we may avoid saying force because now we are going to include the weight of a solid. Then we have the area on the side in which the body is lying on a surface. Then you can have maximum and minimum pressure. You can have maximum and minimum pressure. So maximum pressure is given by the weight of the body over minimum area. This one can be described by the moment you pick the tip of your pen and you press it against your skin. You'll find that you're going to experience very maximum pressure. If you're having your pencil, suppose this is your skin, then now you are pressing the tip of your pen. This is the tip. Of a pen. This is the back. Then in this case, you're going to experience high pressure since the tip is of very small area. Unlike if you press the back, suppose now we have it like this. This is still the skin. Now you have say this pen, the back. So here we're going to have minimum pressure. Therefore, for this one, we have tried our level base that we can elaborate. And this one is for minimum pressure. Which is given by the weights of solids over maximum area. can show this one when you are using examples. For example, if I read this question, which is reading, before you go to the question, we can also try to use a block. So considering a block, then a block, these measurements, you can say this is 10 centimeters, 5 centimeters, and this is 3 centimeters. Then the first part, we need to identify what are the areas. We have an area of area 1, you can say, can take 10 times 5, where we'll arrive at 50 square centimeters. Area 2, when we pick 5 and 3, that is 5 times 3. This one will lead us to 15 square centimeters. Then now we have the last area, area 3, when we pick 10 and 3, representing this part. Then it will be 10 times 3, and this one will lead to us at 30 square centimeters. Then now we can have example. I'm going to put down the example where you're told a block of stone of dimension 4 meters by 2 meters by 3 meters is 48 is of mass so of mass 48 and meant to rest on a horizontal surface. Then method number 1, calculate the minimum pressure it exerts on the surface. Roman 2, the maximum pressure it exerts on the surface. That question can be interpreted diagrammatically, where we can draw it in this manner. It is 4 meters by 2 meters by 3 meters. So now, in this case, you can calculate maximum area, which will be 4 times 3. That is 4 times 3, leading us to 12 square meters. Then we have our minimum area, which will be 2 by 3. 2 by 3. And this one will lead us to 6 square meters. In between, we have an area of 4 by 2. This one is leading us to 8 square meters. So this one, we are not going to use it. It will be of no significance unto us. Then now we can go straight to solve the question where we are being asked about the minimum pressure. So the first thing is that for us to get minimum pressure, can say minimum pressure, P minimum, will be given by the weight of the solid divided by, say, is it of the block divided by the maximum area, A maximum. So that now gets weight of block will be the same as, we are told it is of mass 8 kilograms, 48 kilograms. Then you multiply by G. So 48 times 10. This one will lead us to 480 newtons. Then now we can substitute it there, where we'll say we have 480 as our weight divided by the maximum area, which we have said is 12 square meters. 12 square meters. And this will lead us to 40 Newton per square meters. This was Roman 1. Roman 2, where we are being asked about the maximum pressure, is given by the weight of block over minimum area. This is for 180 newtons divided by minimum area. We have said that it is 6 square meters. And this will lead us to 80 Newton per square meters. That is an example, a working example. We can also give example 2. Example 2. And you're told a block of copper, of density 9 grams per cubic centimeters, 9 grams per cubic centimeters, measures 5 centimeters by 3 centimeters by 2 centimeters. Given that G is equals to 10 newtons per kg, determine A, maximum pressure, B, the minimum pressure. This is an indirect question because we have not been given mass, but it is for you to relate with issues to do with volume so that can get the mass. Therefore, step 1, is you get the mass of this one. Therefore, you can say that density is given by mass over volume. This means that mass will be given by density times volume. We have our density there. Then we are going to extract our volume from this and this. Therefore, density is 9 grams per cubic centimeters. Our volume will be the same as 5 times 3 times 2. This is 30 cubic centimeters. Therefore, we say mass now is given by 9 times that. We arrive at 270 grams. Now from here we can get the weights. Weight of block. Weight is given by mg. We will be having 270 grams. You convert into kilograms. So it will be 270 divided by 1000 times 10, our G. And in this case, we're going to arrive at, first one is 0.27, 0.27. This is 2.7 newtons. So the first question was asking maximum pressure. We can draw this one. So 5 centimeters by 3 centimeters by 2 centimeters. Then you can say maximum area. Let's start with maximum area. A max will be given by 5 times 3. 5 times 3, which is 15 square centimeters. And this one is equivalent to, you divide by 10,000. 15 divided by 10,000, you convert into meter squared, which will be the same as 0.0015 square meters. You can now go for minimum area, which will be 3 by 2. And this is 6 square centimeters, which is equivalent to, you pick it, you divide by 10,000, 0.0006 square meters. Then we can go for the first question, that is maximum pressure. Let's see. Maximum pressure will be given by the weight W over area minimum. This is 2.7 newtons divided by 0.0006, and this will lead us to 4,500 Newton per square meters. We have now, this is A, part B, where we are required to get the minimum pressure. P minimum will be given by weight of the block over area, which is maximum. and this will be 2.7 newtons divided by maximum area is 0.0015, and this is 2.7 divided by 0.0015. You get 1,800 Newton per meter squared. We can now look at factors affecting pressure in solids. The year 2, we have weights of body, and this is bringing out to us the force, the magnitude of the force, and we have the area of contact. Remember, from the definition of pressure is equals to force over area. If you increase force and you hold area constant, then automatically you're going to increase the pressure. But if you hold the force constant and then you decrease the area, then this one is going to rise. If you the P will automatically come down. We can have a special view of how this one affects. That is it. So we have this. We have the weight of the solid. If the area between solid and the surface is constant, the same way I was talking before, the same way I have described over there, then the pressure decreases with the weight. And this means that pressure is directly proportional to the force or the weight. Area of contact of the solid with the surface. The smaller the surface area, the higher the pressure you're going to exert. This means that pressure is inversely proportional to the area of contact. We have some few explanations here where you are told that tractors have wide wheels to reduce pressure exerted on the ground. Remember these ones, they are working on the farm. They are working on the farm. Therefore, if they try to offer maximum pressure, then they are going to have to destroy the farm. We still have elephants have wide legs to reduce pressure exerted on the ground. That is also an effect of the area of contact. It is easier to walk or on sand with flat shoes rather than shoes with a sharp heel. With a sharp heel, they have very minimal area, meaning that you're going to exert a lot of pressure under the soil. And this is same question that is always asked when you're told that if you catwalk with a heeled shoe, then you leave some holes on the way. But if you're having a flat shoe, you don't leave some holes. The reason is explained clearly there. Uh, I can give out the last example. And here is the question. This is the question. A man of mass 84 kilograms stands upright on a floor. If the area of contact of his shoes and floor is 420 square centimeters, determine the average pressure he exerts on the floor. Remember, a man is having two legs. You can have the solution. Pressure is given by force over area. We are given mass of this man. That is why we pick that the weight of this man will be given by mg. 84 is the mass, 10 newtons per kg is g. Then we arrive at 840 newton. Then the area is going to be in contact is 420 square centimeters. I said if you are working this formula of pressure is equals to force over area, then you are supposed to convert each and every quantity that is required to be substituted in the formula to be in its SI units. Therefore, we divide by 10,000 to make it 0.042 square meters. Then the total pressure will be given by 840, which is the weight, divided by 0.042. And you can see from the calculation arriving at 20,000 newtons per square meters. Thank you so much. We shall meet in our next episode where we shall be looking at pressure in liquids. Thank you so much for tuning in. Don't forget to subscribe, you share, and may God bless you. Thank you. Have a wonderful day ahead.